students, this is plus 2 mathematics, chapter 7, applications of differential calculus. In this topic, we are studying about tangent and the norm. In first volume, we studied about the tangent of any curve, so in conic section, right? Tangent is nothing but a straight line. Tangent is nothing but a straight line. It touches any curve at one point. So imagine that this is a curve, wherever this is a parabola, and this is a point. A line touches the point, then this particular line is nothing but tangent. So tangent is a straight line and touches at any point. I mean only one point for any curve, right? What is the normal? Normal is, let us say, a straight line. It is perpendicular to the tangent and passes through the same point of contact on the curve, right? In generally, without differentiation, that is in volume 1, we can find the tangent equation for any curve using x square as xx1, y square as yy1, x as x plus x1 divided by 2, and y as y plus y1 divided by 2, and xy means xy1 plus x1y divided by 2. So we can find out easily tangent equation to the any curve without differentiation. Means we have to substitute x square as xx1, y square as yy1, and x as x plus x1 divided by 2. Y means y plus y divided by 2. Xy means xy1 plus x1 into y divided by 2. Yeah, we want to replace x square like that, and x1 comma y1 is nothing but point of contact. We are substituting this one, we can easily find out equation of tangent for any curve. Now, the same method we are using into differential calculus. Okay, so you see. Now we know very well tangent. Tangent is nothing but a straight line. In line we have a equation, general form, right? General form is nothing but ax plus by plus c is equal to 0. This is a equation of line, linear equation of line, right? Now this is standard form. Y is equal to mx plus c, y minus y1 which is equal to m into x minus x1, y minus y1 divided by y2 minus y1 which is equal to x minus x1 divided by x2 minus x1. Finally, x by a plus y by b which is equal to 1. So these are the standard equations of straight line. So the first one, y is equal to mx plus c. When we want to use the formula, we know slope and y-intercept. If we know slope and y-intercept, we can use this formula, we can find out equation of line. Here, one slope and one point. So this formula we are going to use one slope and y-intercept. The next one point and one slope. Here, 2 points. Here, 2 intercepts. Right? Now, this is ordinary equation of format. Now, we have to study about slope, right? We know very well slope tangent by and tan theta, that is a tangent value of an inclination of angle with the x-axis, that is tan theta. And another one, m is equal to y2 minus y1 divided by x2 minus x1, when the 2 points are given. Okay, so this we are finding slope means this is a point x1 comma y1, this one is a point x2 comma y2. When the 2 points are given, we have to find out slope by using y2 minus y1 divided by x2 minus x1. Next one, m is equal to minus coefficient of x divided by coefficient of what? Y. then the line equation ax plus by plus c is equal to 0. So the line equation given means we have to find out the slope is equal to minus coefficient of x divided by coefficient of y. This is nothing but minus a divided by b. Now, in this case, we are using by differential calculus, right? We are finding the formula by slope. This formula should be transformed into, what do you mean this one, y2 minus y1? This is the difference in y coordinate, isn't it? This is different in y coordinate. So now, difference in y coordinates. So y2 minus y1 is nothing but dy. Dy means difference in y coordinates. And see the denominator, x2 minus x1. x2 minus x1 means what? There is also difference, isn't it? So difference in x coordinates, right? So this m, this is y2 minus y1 divided by x2 minus x1. This slope transformed into as a differential, right? M is equal to dy by dx, but the point of contact, at the point of contact, we get slope, right? So now we have to use, this is the slope of, we have to find out the equation of tangent, right? So m is equal to dy by dx at the point of x1 comma y1. Now we want to recall the formula for differentiation for all the functions, right? Then we are going to solve the problems, right? In this concept, we need three formulas, right? Okay. The first formula, equation of tangent. Equation of tangent is nothing but y minus y1, which is equal to m into x minus x1. Here, x1 and y1 is nothing but point and point of contact, and m is nothing but slope, right? Now we have to find the slope by using differentiation dy by dx at the point of x1 comma y1. This is the equation of tangent. Now we are finding equation of normal. I said already, tangent and normal both are perpendicular. We know the concept. If two lines are perpendicular, then product of slopes gives minus 1. So m2 which is equal to minus 1 divided by m1. m1 into m2 is equal to minus 1 means m2 is equal to minus 1 by m1. So here, instead of m, we want to take reciprocal and multiple with minus, we get the equation of normal. That is y minus y1 which is equal to this m transform into minus 1 divided by m into x minus x1. So this is the second one. And third one, angle between two curves. Angle between two curves. So if you don't take any curves, okay? So you see, now this is the two curve. It is two curves. Nothing but it is a parabola, open upward. These two curves are intersecting at a point somewhere. This is nothing but x1 comma y1. Now we want to find out angle. What is the angle of inclination of these two curves, right? Now how to find out this one? So we want to draw a tangent line through the point of contact for both curves. This one, this is the tangent for this curve, and this one is a tangent for this curve. Now this is straight line. So now we want to find out the angle between these two lines. It is equal to the angle between the two curves. So in two lines has two slopes. So name it as m1 and m2. Using the slope of the lines, tangent lines, we can find out the angle between these two curves. How? They using the formula tan theta is equal to modulus of that, because the angle should not come negative. Tan theta is equal to m1 minus m2 divided by 1 plus m1 into m2, where theta is equal to this tan goes to that side, tan inverse of modulus of m1 minus m2 divided by 1 plus m1 m2. So this is the required formula for calculating the angle between two curves. Let's see the problems. Hi students, this is example 11. Find the equation of tangent and a normal to the curve y is equal to x square plus 3x minus 2 at the point of 1, 2. There one curve equation is given and one point of contact also given. So now we have to find out the equation of tangent and normal. We know very well tangent equation y minus y1 equal to m into x minus x1. The normal y minus y1 equal to minus 1 by m into x minus x1. Here the point taken as x1 y1. So now we want to find out slope m. Okay. So solution. Take the equation now. Y is equal to x square plus 3x minus 2. Now you want to differentiate with respect to x. So differentiation you want to take out the formula d by dx of x power n, which is nothing but n into x to the power of n minus 1. So power comes to the front, then reduce power by 1. Okay, that is d by dx of x to the power of 5 means you want to write 5 into x to the power of 5 minus 1. So 5 minus 1 is what? 4. So x to the power of 5, differentiation of x to the power of 5 become 5 into x to the power of 4 using the concept, right? Next, d by dx of x, what do you get? dx by dx will be cancelled, so it will be 1. Otherwise, using this concept, we can write 1. So 1 into x to the power of 1 minus 1. 1 minus 1 is nothing but 0. So anything over 0 is 1. So differentiation of x is nothing but 1. The same way, differentiation of constant term, any constant term, it will be without x. You see, here we are differentiating the term by x. Here there is no x, so it is considered as it is a constant. So differentiation of constant term is nothing but 0. Okay. Now we have to use apply the concept here. Now dy divided by dx. So dy by dx goes to this one. Dy by dx is equal to. Now dy by dx of x square using the concept. Here treat as 2 here, so 2 into x to the power of 2 minus 1. 2 minus 1 is nothing but what? 1. So this is nothing but 2x. Now 3 is a constant. Now you see x. Differentiation of x is nothing but 1. So 3 into 1. Here constant term, so it will be 0. So dy divided by dx, which is equal to 2x plus 3. This is already differentiation, right? Now we want to find out slope. So slope m is nothing but dy divided by dx at the point of, then given it no 1, 2, that is x1, y1. It seems that dy by dx at the point of 1, 2, which is equal to, you have to substitute here x by 1. So 2 into 1 plus 3. 2 ones are 2. 2 plus 3, so 5. This is nothing but m is equal to 5. Okay. Next, we have to find out the equation of tangent. So we know very well m and we know x1, y1 also. Now, equation of tangent. Equation of tangent is nothing but y minus y1, which is equal to m into x minus x1. So what is m? M is nothing but 5. And what is x1, y1? 1, 2. Now the substituting the value m as 5 and x1, y1 as 1, 2, we get the equation of tangent. So y minus 2, which is equal to 5 into x minus 1. So y minus 2, which is equal to 5x minus 5. So taking go one side, this y taking go y minus 2 to right side, it will be 0 because the left side will be 0. Then the right side 5x minus 1. This plus y goes to that side minus 1. This minus 2 goes to that side plus 2. Now arrange this. 0 is equal to 5x minus y. You see the number minus 5 plus 2. Symbols are different. So you want to subtract 5 minus 2, 3. So it will be minus 8. Then arrange this one. 5x minus 1 minus 3 equal to 0. This is nothing but equation of tangent. Now equation of norm. Next one. Equation of normal. We know the formula y minus y1, which is equal to minus 1 by m into x minus x1. But m is nothing but 5. X1, y1 is nothing but 1. Same value on the substitute here. Y minus 2, which is equal to minus 1 divided by, what is the value of m? 5 into x minus 1. This y taken to left side. So it will be 5 into y minus 2. Here minus 1 into x minus 1. Multiple 5 taken over 5 inside. So 5 into y, 5y, 5 2s are 10. So minus 10, which is equal to here minus x plus 1. So this right side down, bring into left side. So the symbol will be changing. So 5y minus 10. So minus x comes to left side, it will be plus, and plus 1. Right side plus 1 comes to left side, minus 1, which is equal to 0. Now arrange it and simplify. Arrange and simplify, we get plus x plus 5y. Here minus 10, minus 1. Symbols are same, so you want to add. So minus 10 minus 1, minus 11, which is equal to 0. This is the equation of log. Okay, thank you. Hi students, this is example 14. Now, we have to find out the angle between the two curves. Y is equal to x square and y is equal to x minus 3 the whole square. These two curves nothing but a parabola open upward. So first you want to draw the diagram. So the diagram contains one mark. Okay, so you want to draw. Y is equal to x square. The vertex should be origin and it should be open upward. So this is nothing but y is equal to x square. The next one, y is equal to x minus 3 the whole square. This vertex should be 3, 0. So take the point here 3. So the point is nothing but 3, 0. The curve, it also open upward. So this curve is nothing but y is equal to x minus 3 the whole square. Now we have to find out the angle between these two curves. Okay, so this is theta. Before that, we want to find out the point of intersection. What is the point of intersection? X1, y1. And next, we want to draw a straight line. Okay, that means tangent line. Okay, and make it that angle of this angle between these two straight lines is equal to angle between these two curves. So first of all, we want to find out the point of intersection. Next, we want to find out slopes. We know very well the angle between these two curves. The formula is nothing but tan theta, which is equal to modulus of m1 minus m2 divided by 1 plus m1 m2. Right? This is the angle between these two curves where m1 and m2 are slopes. m1 is nothing but slope of the tangent line 1 and m2 is nothing but slope of tangent line 2. Okay, so solution. Let the curves are given curve y is equal to x square, it has 1, and y is equal to x minus 3 the whole square, it has 2. Right? Now, let x1, y1 be the point of intersection. We want to assume that x1, y1 be the point of intersection, right? Now we have to find the point of intersection x1 and y1. We want to solve one addition. You know very well 1 is equal to 2, isn't it? Because left sides are equal. That means right side also equal. Instead of here x, we have to substitute as x1, right? So x1 square, which is equal to x1 minus 3 the whole square. Okay. Now we have to write this is a formula of a minus b the whole square. So we want to expand it. Using the formula a minus b the whole square, we get x1 square plus 3 square a square plus b square minus 2ab like that. Okay, x1 square plus 3 square minus 2 into x1 into 3. So 2 3s are 6, so 6x1. Here plus x1 square plus x1 square both will be cancelled because this plus x1 square goes to that side minus, isn't it? Okay, so this minus x1 going to left side, it will be plus 6x1 is equal to 3 square is nothing but 9. What about x1? x1 is equal to 9 divided by 6. Cancel by we get 3 divided by 2 because 3 3s are 9, 3 2s are 6. Put x1 value into first equation. So first equation implies y1 which is equal to x1 square. This is nothing but 3 by 2 the whole square. We get 9 divided by 4. Hence the point of contact x1, y1 which is nothing but 3 by 2 comma 9 divided by 4. This is nothing but point of intersection. Next we want to find out slope of the first line as well as slope of the second line. How to find out slope using differential concepts? Okay, so slope m is nothing but dy divided by dx at the point of x1 comma y1. So now we want to find out differentiation of first curve as well as second curve. We are taking the first curve differentiation as m1 and second curve differentiation as m2, right? Now see, take the first curve y is equal to x square and differentiate with respect to x. First equation differentiation with respect to x. What do you get? This curve, this is nothing but dy divided by dx. X square is nothing but 2x. Now we want to find out m1. m1 is nothing but dy by dx at the point of, what is the pointer? 3 by 2 comma 9 by 4. So this is the value for x and x1, this is the value for y1. So instead of x, we want to substitute the x1 value here. Then m1 which is equal to 2 into 3 by 2. So 2 will be cancelled. Now m1 is equal to 3. Right? Next, we want to differentiate the second equation. Okay? Now the second equation, differentiation with respect to what? X. What is second equation here? Y is equal to x minus 3 the whole square. Now dy divided by dx. So in differentiation, we want to give the first preference to power. So bring the power. So 2 into x minus 3 or 2 minus 1. Next, inside the bracket. Inside the bracket we have x minus 3. So differentiation of x, 1. Differentiation of 3, that is a constant, it will be 0. So 1 minus 0, nothing but 1, isn't it? So what is it? dy by dx? dy by dx is equal to 2 into x minus 3. Now we want to find out m2. m2 is a slope. This is nothing but dy by dx at the point of, that is a point 3 by 2 comma 9 by 4. Okay? Now find slope here. Just we want to substitute 3 by 2 there. So 2 into 3 by 2 minus 3. So just take and go inside. 2 into 3 by 2 minus 2 into 3. So 2 will be cancelled. So 3 minus 6 which is equal to minus 6. So m2 which is equal to minus 6. So we know very well m1 is equal to plus 3 and m2 is equal to minus 3. Now we want to use a formula. The angle between I will write using this question also, right? Therefore, the angle between y is equal to x square and y is equal to x minus 3, the whole square is tan theta, which is equal to modulus of m1 minus m2 divided by 1 plus m1 into m2, which is equal to, what is the value of m1? 3. So plus 3 minus of minus 3 divided by 1 plus 3 into minus 3. Okay? What do you get? Minus and minus 3 plus 3. So 3 plus 3, 6. Here 1 minus 3 is a 9, which is equal to 6 divided by minus 8. This modulus means the negative term comes to positive. Negative term change into positive. So we get 6 by 8. By cancelling, we get by 2 table, cancelling we get 3 divided by 4. So tan theta which is equal to 3 by 4. It seems that theta is equal to tan inverse of 3 by 4. This is the angle between the curve y is equal to x square and y is equal to x minus 3 the whole square is nothing but theta is equal to tan inverse of 3 by 4. Okay? Hi students, this is example 17. If the curves ax square plus dy square equal to 1 and cx square plus dy square equal to 1 intersect each other orthogonally, then show that 1 by a minus 1 by b equal to 1 by c minus 1 by d. What do you mean orthogonal? Orthogonal means perpendicular, that's all. Orthogonal means perpendicular. Now we want to show that these two curves are intersect at right angles to. Perpendicular means 90 degree, okay? So right angles to. So if two lines are perpendicular, we know the concept of slopes. Using slopes concept we can prove easily whether it is a parallel or perpendicular. We can check it. If slopes are equal, then it is parallel. The product of slopes gives -1, then it is perpendicular. That means now the orthogonally, that means you want to use the concept m1 into m2 which is equal to -1. So you want to take the concept m1 into m2 is equal to -1. Using this concept, okay, you have to show 1 by a minus 1 by b which is equal to 1 by c minus 1 by d. Now you want to find out m1. What is m1? Slope of the first curve. What is m2? Slope of the second curve. How to find the slope? You want to differentiate the first curve. dy by dx at the point of x1, y1. m2 the same way. dy by dx at the point of x1, y1. So differentiation, the curve equation is given, so no problem. But what about the x1 and y1? We don't know the point of intersection, right? So let's see. We want to assume x1, y1 is the point of intersection. Okay? Let's see the solution here. Solution. The given curves are ax square plus by square which is equal to 1. Next one, cx square plus by square which is equal to 1. dy square which is equal to 1. This is the first curve, this is second curve. Next, x1, y1 PD, point of intersection. PD means point, okay, point of intersection. So now the first equation will come like this: a x1 square plus b y1 square which is equal to 1. C x1 square plus d y1 square which is equal to 1. Now, instead of I am finding x1, y1, I am easy to find out x1 square and y1 square using Cramer rule. Okay, by using Cramer rule, we can find x1 square. x1 square is nothing but delta x1 square divided by delta. What do you mean delta x1 square? So using the determinant, right? Delta x1 square, instead of AC, you want to write right side value 1 1. Then BD. Here delta means you want to take out the x1 square coefficient as well as y1 square coefficients, right? AC, BD. Now it is easy to calculate D minus B divided by AD minus BC. Now y1 square, delta y1 square divided by delta. So denominator same only A, B, C, D. But in numerator, instead of y1 coefficient, you want to write right side values. So here A, C, 1, 1. Now A minus C divided by AD minus BC. AD minus BC. So instead of x1, y1, we found here x1 square, y1 square. Okay, you keep it here. Next, you want to find out slope, you know. So now this is the point of intersection, right? Now you have to find out slope. What do you mean slope? Differentiation with respect to the given curve y itself. So take the first equation. So now, first equation, differentiation with respect to x. What is the first equation here? Ax square plus by square is equal to 1. We keep it a. And x square differentiation, nothing but 2x plus keep b. And y square. So we want to give the preference for first power, right? So 2y. To bring to here 2. Then y for differentiation of y is nothing but dy divided by dx. The right side is a constant. We want to assume that is 0. Okay? Now I want to simplify. Here 2 is there, no? So divided by 2, you get ax plus by dy by dx, which is equal to what? 0. So keep it by here. So taking go ax to right side, it will be minus ax. What about dy by dx? So dy by dx, which is equal to minus ax divided by by. So now slope m1. m1 is nothing but dy by dx at the point of x1, y1. So instead of x and y, we have to replace x and y as x1 y1. We get minus ax1 by by1. Similarly, we can find out m2 also. You see, the first equation and second equation, a replaced by c, b replaced by d. That's all. Otherwise, these two equations are same, isn't it? So instead of a, we want to assign c. Instead of b, we want to assign d. Hence, the slope will come automatically cx1 divided by dy1. So m2 also we found easily. What is the condition? This curve intersect each other orthogonally. Orthogonally means I told already it is a perpendicular. So we know slopes. So perpendicular concept m1 into m2 which is equal to minus 1. Hence, since the curves are cuts at orthogonally. Orthogonally means what? Implies m1 into m2 which is equal to minus 1. What is the value of m1? Minus ax1 divided by y1 by1 into minus cx1 divided by dy1 which is equal to minus 1. Multiply, we get plus ac, minus into minus plus ac, x1 into x1, x1 square divided by, here d means dd y1 square which is equal to what? Minus 1. So take both dd y1 square to right side. So ac x1 square which is equal to minus bd y1 square. So bring it here. Otherwise, just the substitute the value of x1 square, the value of y1 square, I have this, I have here. So a, b, c, d and 1, 1. So what is the AC? That means what is the x1 square? X1 square value is nothing but, instead of this one you want to arrange, here BD. D minus B divided by AD minus BC. AD minus BC is equal to minus BD. What is y1 square? So y1 square, instead of this one you want to write, so A minus C divided by AD minus BC. Okay. So you see the denominator AD minus BC will be cancelled. So what is the remaining term? AC into D minus B which is equal to minus BD into A minus C. Multiply with this term ACD minus ABC. Here minus ABD plus BCD. Now divided by ABC. Divided by ABC. What is it? ACD divided by ABCD minus ABC divided by ABCD is equal to minus ABD divided by ABCD plus BCD divided by ABCD. So ACD will be cancelled, so 1 by D. Here ABC will be cancelled, so 1 by D which is equal to, here ABD will be cancelled, so minus 1 divided by C. Then plus BCD will be cancelled, 1 by A. So take into 1 by B here, bring 1 by C here. So minus 1 by C comes to this side, plus 1 by C. So 1 by C minus 1 by D which is equal to 1 by A plus 1 by D goes to that side, minus 1 by D. So this is the required solution. Okay, 1 by C minus 1 by D is equal to 1 by A minus 1 by B. Okay, thank you.